All right, guys, so this is going to serve as our review for our topic 5 test on data distributions, which is going to be on Wednesday. Okay, this recording is obviously posted for you guys. So you guys have Friday night, tonight, Saturday, Sunday, Monday, and Tuesday to use this as a review along with what we do in class on Monday and Tuesday to blow out our test, which is on Wednesday. Okay, once again, if you are not planning on being here in school on Wednesday, you must meet with me to take it either Monday or Tuesday, okay? We went through a lot of different ways to represent data sets and a lot of different scenarios, so we're going to go through each one, okay? We're going to go through dot plots, histograms, box and whisker plots, some scatter plots, and then this slide right here, we haven't seen before, so I'm going to go over that very briefly because there is a question on our test that pertains to that. Okay, so I'm going to start with dot plots first, excuse me. All right, now dot plots use a number line to represent the data set. As you can see, we have a data set right here. Okay, so when we have a dot plot, like I said, we're on a number line here. All right, and we use dots, we can use X's, all right, we can use any symbol really to represent one of those values, okay? And the points itself, the dots or the X's or whatever you want to use, that represents the frequency of how many times that value is appearing in the data set, okay? So if we were asked to create a data plot or dot plot, and we were asked to analyze a dot plot, first thing we need to do is figure out all the numbers that we have, okay? So I see 7, I see 8, I see 9, I see 10. All right, so my number line will probably be somewhere between, 6, 7, 8, 9, 10, 11, 12, all the way up to that biggest number, which is 14, okay? And I just use 6 just in case, but that smallest number is 7. Okay, now at each one of these values, we're going to place a dot or an X, and for this I just use dots since we have dot plots. For this, we're going to place the amount of dots for each time we see that number. So here I see 7 twice, so there's going to be a dot here and a dot there, okay? I see 8 3 times. Dot there, there's 3 dots for 8. All right, the frequency for 9 is 2 times, so that's a dot there. The frequency for 10 is also 2 in there, 2 there. For 11, we have it 3 times. And then for 12, we have it twice. 13, we have it twice. Okay, and 14, we also have it twice. Okay, so this data set, this dot plot represents the data set that we've been given. Okay, now if you are given the reverse, if you're given a dot plot and you're asked to match whatever set represents the values, you just have to count how many times those dots are appearing on top of what number, and then count them in the data set as well. Okay, like I said, that represents frequency. Now I'm going to mention this in the later slides, but okay, let's say we had a value that's just completely nowhere near any of the other values. So let's say we had 1, let's say I added a 19 here. Let's say we had a plot over here. Okay, as you can see, there's a big distance between that plot and the other plots, okay? This is what we call an outlier. Okay, an outlier is a value that is either much larger than most of your data plots, or it could possibly be much lower, okay? And we'll go into exactly how an outlier will affect your data in the next few slides, but that's the basics for a dot plot, okay? The dot plot is actually one of the least used types of data sets that we'll see on our test, but we're going to have to know exactly what that is. Okay, remember when we were measuring center and spread? Okay, so we can assume that the median, obviously for this dot plot, would be somewhere in the center of the data plot or the dot plot itself. Okay, we have the data set here, so we can most definitely just go ahead and, if I erase this 19, it's not there. If we cross out just to get to the median. Remember, if you have an even number, you're going to have 2 numbers in the middle. All right, it looks like we have, let's see, 1, 2, 3, 4, 5, 6. Yeah, so we have 18, so that's an even number, so we have 2 in the middle. Okay. Please come to the front office. Sorry about that, guys. So we have 10 and 11. If we have 2 in the middle, we add up, divide by 2. All right, so that middle number is going to be 10.5. That would be our median. We can figure that out just by looking at the dot plot here, because we can take these dots and then we can start drawing them here if we wanted to, okay, and so on and so forth. Okay, so that's dot plots. Remember, you guys can pause this, you can rewind it, you can do anything that you want. All right, just in case you guys didn't get what I was going over. Okay, now we're going to move on to histograms. Okay, now we went over this in our notes when I wasn't here. Okay, so histograms are similar to bar graphs, but they're not really the same. So bar graphs gives you values, histogram represents frequencies. So for example, in this histogram here, okay, we're comparing age of members and the number of members, okay? So the age and the number. So right here, this represents 6. So there's 6 members who are in the age of 20 to 25, okay? We don't necessarily know what those ages are, all right, but that's a frequency. So there's 6 members from the ages 20 to 25, okay? Here's that word again that we just discussed, outlier. So if I'm looking at the main portion of my data set here, okay, and then I see this little bitty guy out here, okay, that's not really close to my data set, that's what represents an outlier. Okay, once again, an outlier can be much larger than your data set, or can be much smaller. Okay, now what do you think will happen to the mean if the outlier is removed? So if we're looking at a histogram, we don't necessarily know what the mean is because we don't know what these values are. Okay, but when you have an outlier that's much bigger than your data set, that's going to increase your average. All right, that's just like you guys getting, you know, maybe 70s or 75s on an average of your test, and then you get a 95, and that's going to really bring your average up. Okay, it's the same deal here. So if we were to take out an outlier that's much bigger than our data set, okay, that's going to decrease our average. Okay, and vice versa, if we take out a much smaller outlier, that's going to obviously have the opposite effect. It's going to increase our average. So just like, you know, a teacher may drop your lowest test grade, okay, your lowest test grade, that test grade is what's bringing your average down. All right, so if they drop that lowest test grade, that's obviously going to bring your average up. Okay, so those are the effects that your removing an outlier will have on your data set, and we will have to know what that effect is on our test for Wednesday. Okay, now what do you think will happen if an outlier is added? Okay, well, it's the same thing. If we add an outlier that's much bigger than our data set, okay, that mean is going to increase. And if we add an outlier that's much smaller, it's going to bring down our average, okay? So just think of it as that example I just gave you, those test scores and stuff like that. Okay, now if we're looking at a histogram and we're asked what is the mean, what is the median, okay, well, it may be a little hard for us to see in this histogram just by looking at the bar graphs, but what we can do, we can take those frequencies and write out our data set. So here we have the age of 15, how many times? Just 2 students. So that's 15 2 times. I'm writing out my data set. Here, 16, how many times? 5 students. So that's 16, 16, 16, 16, 5 times. Okay, here is 17, that's 17 6 times. 17, 17, 17. Okay, I have 18 5 times, so that's 18 here. I'm gonna have to bring it down, sorry guys. And then I have 19 2 times, right there. So 19 2 times. Remember, frequencies. Okay, so how would we figure out the mean? We know how to figure out the mean. Add these all up. And then we divide by the number of values that we have. Okay, and our median, we know how to find the median. All right, all we have to do is find the middle number. Okay, so if we're asked to distribute between 2 different histograms, that is something that we're going to have to be able to do, to look at a histogram and create that data set. Okay, and you most definitely will have paper and pencil. As you can see, we're definitely going to need paper and pencil to get through our test next week. Okay, next data set. All right, box and whiskers. Okay, this is another type of data distribution that you guys went over in your notes on Thursday and I was not here. Okay, so how can we create a box and whisker from a set of data? Okay, and I will say this type of data distribution shows up the most on your test. Okay, first off, we got to get our data set spelled out for us the best way that we can look at it. I think you guys view the data set in order from least to greatest best, so we're going to go ahead and do that. Okay, so we have miles per gallon and the number of cars that run on that miles per gallon. So we have 28 2 times. We have 29 3 times. We have 38 times. 1, 2, 3, 4, 5, 6, 7, 8. We have 31 5 times. 3. And then we have 32 2 times. Okay, so in a box and whisker plot, okay, it's right above a number line. Okay, so creating a number line first will help. And just looking at our range of numbers, okay, our smallest number is 28, our biggest number is 32. So our range in our number line does not have to be that big. Okay, so I'm just going to go ahead and do 25, 26, spread them out a little bit, 27, 28. I'm sorry for that little thing there. There we go. Oops. Doesn't want me to move it down, looks like. Okay, we're going to have to keep going. 29, 30, 31, looks like I'm giving that line here. 32. Okay, so that's what we're looking at there. All right, now the box and whisker has 5 parts. Okay, it has the lowest number, the biggest number, the first quartile, the third quartile, and then it also has the median. I'm sorry if you guys can't read that. Okay, there we go. So the lowest number represents a dot. Okay, it's the lowest dot. So the lowest number in this data set is 20. So we're going to put a dot right above 20. The biggest number represents a dot as well, and that's going to be at 32. Okay, so our box is going to be in between these 2 points. Okay, now our first quartile is where we're going to start drawing the box. All right, but in order to find our first quartile, we obviously have to find our median first. Okay, so our median for this problem, I'll go ahead and start figuring that out. You guys can actually pause me right now if you wanted to figure it out yourself. Okay, and then click start to see if you got what you before or not. It looks like our answer is going to be 30. Let me just make sure I didn't, mess up anything. 1, 2, 3, 4, 5, 6. So yeah, I got 20. I got 2 in the middle. Okay, they're the same number. I know it's going to be 30, but just to continue the practice, that's 60 divided by 2. So our median is 30. So that's where the other dot should go, and that's actually where the center of that box is going to go. Okay. Now our first quartile. So if 30 is right here, okay, we're going to use this side here for our lower half. We're going to use this side here for our upper half. Okay, so the median of the lower half, which is our first quartile, is here, 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 here. It looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got 2 in the middle again. 29 and 30 seem to be in the middle. So that means 29.5 is going to be our median. 29 plus 30 divided by 2 will give you 29.5. For those of you that are wondering. Okay, so 29.5 will be right here. So that's where the other part of the box will go. And our third quartile is going to be in the middle of the upper half, which is going to be here, 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 here. It looks like 31, and 31 we're in the middle. 31 plus 31 gives me 62. Divide that by 2 gives me 31. So 31 looks like our third quartile here. Okay. So once we have that box, we're going to draw that line to that other point and connect it. All right. And that is our box and our little whisker out there and out there. That's our box and whisker plot. Okay. So that's how we can create that. All right. Now we may have to create it. We may have to pick the answers or create the answers or find the answers from a box and whisker plot that's already given to us. Okay. Remember, this is our Q1. median. I'm going to go ahead and erase this. This is our Q3. This is our biggest. And this is our smallest. Those are the 5 parts. Okay? Make sure you pause if you need to, because that's really, really important. Okay? Now moving down, all right, these words here, what about skewed? What does that even mean? Okay? So when you have a data set that's skewed to the right, that's kind of the same thing as having an outlier. Okay, so if you have a data set that's skewed, all right, that means you have some group of numbers or possibly just one number that is not around your the majority of your sets at all. So right here, okay, remember this is the smallest, this is the biggest. Okay, this is just another example. It's not the same one, so we moved on. This is our median. This is our third quartile, so our Q3. This is our Q1. Okay, as you can see, the majority of my points lie in this area, but we still got a point that's all the way over here. Okay, so when a data set is skewed, that means you have some type of outlier to the right or to the left of your data. Now, this is skewed to the right because the outlier is to the right of your box and whisker set. If it was flipped and the smaller number was much farther away from your data set, it would represent skewed to the left. Okay, we're going to go ahead and hit on interquartile range, okay, simply because this is something that we've gone over in the past, but we still need to make sure we remember how to do. So our IQR equals our Q3 minus Q1. So for this problem here, it looks like our Q3 is right in the middle of 8 and 12. The number between 8 and 12 is 10. And this one, my Q1 is right on top of 4. Okay, so 10 minus 4 would be 6. My IQR for that problem would be 6. Okay, understanding that this is your smallest number, this right here is your Q1, this is your median, this is your Q3, and that's your biggest. That's really important when it comes to IQR and questions of that nature. Okay, when we talk about the mean, remember, mean is a way to measure the center. Okay, so our mean, all right, even though we don't have the data set for this box and whisker plot, all right, our mean is going to be somewhere in the middle here, close to that median. So somewhere between 7 or 8, okay, or possibly 5. All right, that's something that you guys have to keep in mind as well, because mean is a measure of center, along with median being a measure of center. Okay, moving on, scatter plots. Okay, how do we predict values for the scatter plot? Okay, so example, what would be the height or the prediction for the height of the plant in 6 months? So we're looking at time and we're looking at height for this plant. Okay, so predicting, what do you think that would be? Well, look at the trend of the points. The points look like they're going up this way, right? The points look like they're going up that way. So if that continues to happen, this is a positive association. I would go as far as saying it's a strong positive association because those dots are really close to that trend line. All right, so if that continues to go that way, all right, where do you think that height will be after 6 months? It'll probably be somewhere around here, right? So it would probably be somewhere between, 6 and 7, maybe a little higher than 7. Obviously, it's an approximation. Approximations are not exact. It's a prediction. So that's how we would predict that, okay? Now, you'll be taking the test on your iPads, so you may have to take a pencil and create your own line of best fit, or you guys can just look at it. Okay, now this is one thing that I don't think we went over enough, and that's completely my fault, but it is in your notes. Some of you guys, some of you periods, I kind of skipped over it. Correlation coefficient, okay, and all that means is how close are those points to your line, okay? If you have a positive correlation, your correlation coefficient will be positive. If you have a negative correlation, your correlation coefficient will be negative. Now in class, we talked about how strong and how weak something is by just looking at the trend, okay, how close the points are to the trend line. We can also do that by defining a correlation coefficient. There is a formula for you guys to calculate the correlation coefficient, but in Algebra 1, you do not have to know what that formula is. A question will not ask you what is the correlation coefficient. It'll ask you questions like, what does this correlation coefficient actually mean? Okay, so when we get into strong versus weak, right, a strong correlation coefficient will be a number that is close to +1 or -1. Okay, when we have a weak correlation coefficient, all right, it'll be closer to +0.5 or -0.5. Once again, you do not have to know how to find it. You just have to be able to answer questions about it. Okay? So with that being said, for example, if a question asks you the scatter plot or tells you the scatter plot has a correlation coefficient of, let's say, CC correlation coefficient, let's say -0.85, and it asks you what does that mean? This number is pretty close to -1. So this is going to represent a strong, and look at that sign there, okay, a strong negative correlation, okay, meaning whatever you're comparing, whatever two variables you're comparing, there is a strong effect on those two variables based on what it is that you are looking at. All right, and if your correlation coefficient, let's say it was +0.32, all right, that's closer to 0.5 than it is to 1.0, all right, and it's positive. So this is going to be a positive weak correlation because it's closer to 0.5. So keeping these numbers in mind here is what's really important when it comes to correlation coefficient. There will be 2 questions on your test about correlation coefficient. So it's really, really important for us to pay attention to those. Okay. Last but not least, which equation best represents the scatter plot that's to the left? Now we did go over this in class. Okay. In order for us to estimate what that line is, we first have to go ahead and draw a trend line. Okay. Now you won't have a drawing tool for your test. Okay, but we still need to know how to create that equation. All right, so we need to find 2 points that are close to the line. Okay, choosing 2 points that are close to the line and then finding the slope of those 2 points is going to give us a slope of the line. So the closest points I would say are right here and right here. Okay, so that first point, it looks like, and you guys may have to estimate, it looks like, 15 and 7, the number between 50 and 20 looks like 17, all right, and it looks like it's on 10 for weight. So my X will be 17, my Y will be 10. And over here, it looks like it's in between 25 and 30, and it's on 14. So 27 is in between 2 numbers, and then my Y value will be 14. So those two values are the values I'm going to use for my slope. Okay, so -2 minus -1 over x2 minus x1. So that's 14 minus 10, 27 minus 17. And if I simplify that, it looks like I'll get 2/5. Okay, 2/5 will be my slope. Now, the easiest equation to write your equation in is slope-intercept form. So that's y equals, my slope is 2/5. I still got to find my y-intercept. How do I find my y-intercept? Choose one of those points and plug it in. It doesn't matter if it's this point, or any other point that's on the line. I'm just going to go ahead and choose 17 and 10, I guess. So 10 is my y, 17 is my x. Guys, don't freak out. You may have to deal with fractions. You may have to deal with decimals. Don't freak out. Okay? 5. So that looks like 17 times 2 is 34. 5 times 1 is 5. And you know what? Well, it's okay. I can use a calculator. 34 5. 6.8. If your answers are in decimal form, you gotta have to change to decimal. That's fine. Okay, and my last step will have to be, sorry, I gotta extend the page. Subtract by 6.8. That should give me 3.2. All right, so coming back up here to my original equation, y equals 2/5 x plus my y-intercept, which is right here, 3.2. Now, when you are looking for those values, guys, just because you don't see the exact equation in one of those options for multiple choice, don't think that you did anything wrong, okay? Remember, it's approximation, okay? You have to choose the equation that's closest to this right here, okay? That's closest to that, all right? So that will be a question on your test as well, okay? And on the last slide, guys, like I said, this is something that was not in our notes, and it's something that is going to show up on your test, all right? It's a pretty simple concept. It has to do with how close points are to a line once again, and it's called residuals. That's what we call it, residuals. Okay, there's three examples here. Okay, so when you're on a residual graph, you've probably never seen a residual graph before. But what it looks like is this line that's right here, okay, that represents your trend line. So instead of it being in a diagonal, that represents your trend line. So when you have a residual graph, all right, you can determine just how strong that correlation is by how close those points are to the line, okay? So this first example, if you see points that are just random, just plotted all over the place, and they are typed, meaning close to the line, that means the line that is drawn, or the trend line, fits the data very well. There's a strong correlation there, okay, so it fits the data very well, okay? If we look at here, this example, there's random points, yes, but they're not close to the line. They're not tight. They're loose is what we call them, okay? So that means that the line fits the data, but the model is actually weak. So that's a weak correlation, okay? And our last example, if we see points that are not random, you guys see how this is like kind of in a pattern? So that's like a V pattern, okay? And they're not close to the line. This means that there's no correlation. That means that that line does not fit that data well at all, okay? So looking at this example here, okay, looking at these two residual graphs, all right, what can we conclude about the residuals shown here? All right, well, this is my residual line. Those points are really close to it. So this is a strong correlation, meaning the line fits very well, okay? And over here, all right, this is my residual line. And those points are random, but they're not very close. So I see that they're random. So that means there is some type of correlation, but it is a weak correlation. Okay. So like I said, this is probably the slide that you guys need to review the most, simply because we haven't seen it in class. All right, but there is one question on your test about residuals as well. Okay, so that's all we have, guys. All right, we have a bunch of different data distributions, and it's going to take some practice, especially over the weekend and Monday and Tuesday, to get down the questions that you guys have. What I would really like you guys to do is to review this video as much as possible between now and Wednesday, so that you guys can come up with any questions that you need from me. Okay, and if you guys are looking over this over the weekend and you have a question about it, please, please, please do not hesitate to reach out so that I can help you guys with it. Okay, once again, our test is on Wednesday. All right, I have the utmost just confidence in you guys that you guys are going to blow this one out. It's the last one before the holiday break, guys, so let's make sure that we're really prepared and ready for it. Okay, I'm really, really anxious and excited to see what these scores are going to be like. Okay, so I'll tune in with you guys next time. I know you guys like these videos. I'm going to try my best to continue to do more of them as much as possible. Okay, it's just kind of time consuming, but like I said, I will try my best. And like I said, if you guys have any questions, Mr. Porter is out of here.